On this week at the Brumby build, we're doing the axles, specifically the rear ones, and we have to take parts from these, and maybe even that, in order to get power to our back wheels. You'll notice I'm dressed all in black because this is bound to get messy. Okay, so what are we looking at here? Well, basically, we have to get power coming out of the rear diff to each one of the back wheels. This is the Brumby's original rear axle, and this is the Outhouse's original rear axle. If you're wondering why I'm calling that an outhouse, you'd have to go back to the original video in this series where I purchased a Subaru Outback to use in this project as the donor vehicle, and it got the nickname of the outhouse. That's what this came out of. It's not actually as great a difference in length as you would think. I mean, obviously the Brumby is a narrower car than the Outback. A lot of the difference in length is taken up by these male splines that are on the end of the Outback and female splines on the end of the Brumby drive shafts. So that accounts for a fair bit of the length. Also bear in mind that on the Brumby one, on the hub here, we have a hub shaft that extends out. So the overall length from this face to where the nut goes on the end to hold the drive shaft into the hub is actually a lot less than what you would expect. It's actually only around about maybe 25 mil, maybe 30 mil difference between the Brumby and the Outback in terms of the overall length once you have all the components in there. That's obviously times 2 because you have a left and a right side, but anyway, the difference isn't as big as I thought it was going to be. What I could do is take these splines off the Brumby diff and transfer those into the Outback diff, and that seems to be the way that most people go, so I potentially am going to have to wind up doing that. But in the meantime, I thought I would just have a look at these, pull these apart and see what's actually going on inside there. So this will be a new exercise for me, a new experience. I've replaced CV boots before, but I have never pulled one of these apart with the intent of seeing if I can mix and match parts to make up a whole new drive shaft. But I want to have a look in here because apart from anything else, this one, it's just not, it catches in there. It's not as smooth as I would like it to be. That's part of the reason why I want to pull these apart, and just for my own knowledge, because doing research about this online, no one actually seems to pull these apart and show you them side by side so you can see which bits you can swap over and which bits you can't. But anyway, let's give that a go. Should be pretty simple. These boots just pull off at the CV end, and on the shaft end they've just got clamps, and I've got replacement clamps, so we should be all good there. Let's pull it apart and see what's inside. Okay, so because these boots are still intact, I want to try and get these clips off without damaging the boot if I can. Oh, okay, so what I thought was just popping off at this end, it's just a cover. Yeah, okay, that's cool. Now this is potentially where it starts to get messy, because inside here we have a whole lot of grease. Isn't that lovely? Now there should be a retaining snap ring in here according to the manual, and all I can see is a whole heap of grease. So let's grab some paper towels and see if we can get some of that out of the way. Alright, you can tell things are getting serious because I'm busting out the manual already. Using a suitable screwdriver, remove the retaining snap ring from the outer race. Okay, so not a lot more in the way of clues there, but this is our outer race. So where is our snap ring? Ah, yeah, and there we go. In here, just at the edge, and you just use a little screwdriver, and out she pops. So yeah, there's our snap ring. And then we have the ball bearings in here. I'm guessing this will have a snap ring on there that holds it in place, does it? Mark or note the installed position of the outer race to the joint cage. Oops. Should have read the next step, shouldn't I? That's not going to be so easy to work out now. I presume that's so that you align it correctly when you put it back together. Is there any way I can figure that out? I didn't rotate him and he was out this way, so I think it must be that way. Oh, I know how I can figure it out. I can figure it out from the angle of that versus the angle of this. Maybe I'd better go back and check my footage and then I can figure it out. Okay, so it is useful recording this stuff. So yes, I had to go and get the video footage off the camera onto the computer, but I was able to get a screenshot of it, and the arrow on here broadly lines up with the pin on here. That means I actually guessed it right. Now then, next step. So now we have to carefully remove the balls from here. Let's get a little packet to put them in, eh? There's another one. Now the manual doesn't mention that I have to keep these in order, so I'm not going to. Turn the joint cage. Ah, I see what they mean. Okay, so you rotate that until it lines up with this, and then it'll push inwards. Oh, we're going to need circlip pliers. Aligned in there. Squeeze, and off she comes. Now, do I need to keep the alignment of this? One would imagine you'd have to, otherwise what was the point of keeping the alignment of the other one? This manual is really annoying me. Again, note or mark the installed direction of the cage. Well, you got me to move it like 2 steps earlier. See, this is where a little bit of knowledge can give you false confidence. Maybe I shouldn't have been pulling these apart anyway. This might be an instance of where my ambitions outweigh my talent. I'm thinking that was the sequence. I feel like this is asking an awful lot of this pen. Wow, that's pretty incredible actually that it'll mark that. And now we can pull this off. Now we have everything aligned. The boot off now. So as a very minimum, I'm going to have to replace all this grease in here. Now I do have a tube of grease on order, so I will be able to do that in due course. I've just got to figure out whether I'm actually reusing these or not, I suppose. Okay, I'll get these guys cleaned up and then we'll do the same process with this one, eh? And let's check our spline counts and stuff. Maybe we can swap those outer races over to this. Probably not, but it's worth looking at. After a little bit of cleaning, and I've just gone through and etched a little mark on each one of these components so that I know which way they go and I don't have to rely on that paint which could come off. So this is the guts of it really. This is the core heart of the CV to allow for your suspension going up and down, and these two are kept in alignment by those balls, and they lock those two bits together so that they rotate together but they can pivot independently. This inner race goes on here. And he's just held in place with this snap ring. So yeah, he just goes on the end of the shaft and he's fixed in place. This one with the balls inside it sits inside here, which is fixed to the hub shaft. So that will be going up and down with the suspension. Now looking at it all, because I felt a little bit of binding, I suppose, when I was articulating it while it was all fully assembled, I expected to see some damage in here, but they actually seem to be all right. My understanding is it doesn't take much of an imperfection in here for you to get a clicking and stuff through the CV, but these feel really, really good. Same with these. I mean, around the edges, there can be a little bit of a lip, but the actual surface, and you can see where the balls are sitting just from they're polished. I wouldn't go as far as saying worn, I'd just say they're polished. So yeah, I'm surprised I was getting some binding in it, unless it is the balls. Do the balls wear? Maybe. Maybe I've got worn balls. Anyway, regardless, the final piece of the puzzle really is this snap ring that goes around there and retains the ball race within the outer race. The grease used in CVs is slightly different to your normal axle grease. It's more tacky to help prevent it being flung off through centrifugal force. But what I might do is put those parts off to one side. I know that's one complete end. And then this is the end where it really gets interesting. So on these rear shafts, the outer end, we need to use the Brumby outer race because that's going to go onto our hub shaft. That's got the right shaft size, spline count, all that sort of stuff. That will go straight onto our hub shaft. But then of course, our Brumby diff had these little male shafts and our EJ diff doesn't. So what I wanted to find out was whether it is as simple as taking that off there and popping it onto here. Now, in order for that to work, you would need the ball race for this to fit inside there, or you'd need the inner race off that to fit the spline on the Brumby shaft. I don't know if either of those are going to work. I feel like that is an extremely long shot, but like I say, I wanted to pull these apart because I wasn't sure whether they would be usable anyway, so I might as well keep going with the process, and then I can pull the EJ one apart, at least the diff end of it, and see whether I can somehow adapt all of that to go on here and replace this end. Okay, so I'm about ready to move on to the outhouse shaft now. The Brumby one, I've got it all fully disassembled. All the components for the CVs themselves are all labelled and individually boxed so that I've got the two ends separated. Now, what I did learn was that we have a 22 count spline on the ends of the shaft. All I really need to pull apart is this end. This is the diff end. And before I go too much further, I might just get my engraver and mark these. Look at me learning as I go. Learning from past mistakes. All right. Again, let's try and get the spring clip out here. There he is. This is promising so far. It looks like a pretty similar design. All right, so there's our outer race off. Okay, this housing does look different. Oh, dropping my balls already. Well, it does have 6 balls, same ball count. Try and get rid of this grease without getting rid of my my mark identifying the orientation of it. Told you guys this would be a messy job. Where's my circlip pliers? There. There we go. Oh, he's stuck on there. Yeah. There it is. Let's count those splines. Or in fact, let's actually just do a... Oh no, they do look different. I'm pretty sure that won't go over there. No, it won't. Okay, well I shouldn't really be surprised by that. Alright, so after a bit of a clean up, I'm afraid I don't have good news. So basically there's no way to cobble these together. My plan had been to try and replace this guy at the diff end with this guy. Not going to happen. Not with these parts anyway. So what have we got here? Well, this is our Brumby shaft, and what I've learnt after cleaning up all the bits is that the spline on the inside there is different. This inner race that holds the balls for the CV, that is even a different size between the two. And this cage that holds the balls is a different diameter. The balls themselves are actually a slightly different diameter. And then of course this star socket that they fit inside this cup is also a different diameter. So none of it fits. No combination of those parts will actually work. Which leaves a couple of options. This of course is the Brumby's diff, and you can tell that because it's got the male shaft coming out the side of it, the stub axle, whereas the Outback's one has a female socket there and the male part of the connection is on the axle. What it appears I can probably do is pull this apart, the Brumby diff, take these stub axles out and transfer those over into the Outback diff, thereby converting the Outback diff to use these, and then I just use the Brumby half shafts or axle shafts as they came from Brumby. And that would be nice and easy, and in theory probably actually the cheapest option. So why aren't I doing that? Right, well, a couple of reasons. One is once I start pulling these apart, everything that I've seen has only been about doing this changeover on an open diff. I want to use the Outback diff, which is a limited slip. The problems are a couple-fold. I need to keep the Outback diff ratio, which is the ratio that the input shaft turns in, compared to the output shafts. So with a four-wheel drive or an all-wheel drive like the Subarus, the rear diff has to match the front diff, because otherwise your two axles are going to be trying to turn at different speeds, and that's just no good. Horrible things will happen. So we need to have the right ratio. So we've got to use the Outback ratio. As I say, I want to use the Outback center. If I can just take these parts out, these stub axles and this housing and all that sort of stuff, change it over to the Outback diff, then in theory everything will be fine. I've not seen conclusively that it is possible to do it with the limited slip. And of course, once you start pulling it apart, then you're starting to need to replace seals and gaskets and all the rest of it. The other big doubt that I've got is, in terms of pulling this apart, inside here, there is what's known as an E10, external Torx. That's what the E10 socket looks like, and you can imagine the bolt for that is inside here, inside this stub axle. Now, my issue is that this E10 doesn't fit. So it only goes in that far, the skinny part of it, whereas the bolt in here is actually all the way down at the bottom. It starts after where this roll pin goes through the axle, which is halfway down the stub. So I can't get that out without buying a new tool. Now that's not the end of the world, but that does highlight another issue. The reason why I think Subaru changed is this obviously is hollow for that E10 Torx. This, which is the male equivalent of that from the later model diffs, is solid. Obviously that is going to be a lot stronger than the hollow one. And if you look at the shaft even, this is solid, and the same with the hub shaft that's at the other end out here, also solid, which means this becomes the weak point. Now, is that going to be an issue? Well, I don't know. Bear in mind the Brumby from the factory came with 60 kilowatts, and the EJ25 that I'm putting in there is rated for over 120, so it's literally more than double the amount of power going through this. Not to mention that on the Brumby, this is only being driven when you're in four-wheel drive, and that only happens when you're off-road. So it's only ever actually engaged when you're on soft, loose material in the Brumby, which means there's not a lot of grip from the tyres, and therefore that softens the blow through here. If anything's going to slip or be in danger of snapping that, well, you'll probably just spin a tyre before that happens. Now, with the outhouse being all-wheel drive, that's got power going through it all the time, even when you've got perfect grip. So if I do a hard launch or something like that, double the horsepower, full grip on tarmac or something like that, am I going to share that off? I mean, it's a possibility. I'm sure Subaru changed this for a reason, and I reckon that would be the reason that this just isn't as strong. So my thought pattern is, I can go to the trouble of trying to change this out. It's going to cost me money to attempt it, because seals, gaskets, etc., plus the tool. And am I better off just to find out the cost of getting this CV adapted so that it uses this? Basically what I've just tried to do for free here, maybe I'd take this to a professional shop who can make up a custom half shaft, and that will be a stronger option than doing this, and it might not actually be that much more expensive. I'm not sure which is the best option. Anyway, let's crack on. Let's get this assembled, go talk to the professionals. Okay, after a few phone calls around and a little bit of running around, I managed to find someone that should be able to do those. The bad news is he can't do the rear axles or even give me a quote till next week. So I'll pop in and see him again next week and run through exactly what's needed. But at least there's someone local that can do that work for me, which is good. The front axles and the main prop shaft or the main drive shaft from the gearbox to the diff, he won't be able to do those yet because I still don't know the exact dimensions for those, but at least he'll be able to show me how to do the measurements for those so I know how long they need to be. But at least if I can get the rear end sorted, I think by the time I'm able to get a quote from him, I should hopefully have the last of the brake bits in my hands, and I can do the brake work down the back. So yeah, it might all start coming together at the back end at least next week, which would be good. So that doesn't leave me a huge amount to do today other than clean up a little bit of a mess around here and maybe start editing this video. So I'll sign off at this point, but thank you all for watching, and I'll catch you guys on the next episode of the Brumby Build. See ya.